Hello everyone and welcome back to our channel. In today's video, we are going to talk through Chip War, the Fight for the World's Most Critical Technology by Chris Miller, published in 2022. The semiconductor industry is at the forefront of shaping the modern world, with its far-reaching implications on global economics, military power balance, and technological advancement. This discussion delves into the geopolitical ramifications of the semiconductor industry and its profound influence on the global economy and military capabilities, focusing particularly on the intense competition and technological advancements within the field. Key players such as the Taiwan Semiconductor Manufacturing Company, TSMC, and the implications of companies like Huawei are emphasized. Furthermore, examples of the broader implications of chip manufacturing are explored, particularly through instances like the USS Mustin's mission in the Taiwan Strait and the US-China semiconductor rivalry. The comprehensive examination of chip technology sheds light on its pivotal role in the global economy and military capabilities. The history and exponential growth of chip technology are explored in depth, underscoring the critical role it plays in shaping the modern world. There's an emphasis on the meticulous development of the semiconductor supply chain, along with an exploration of major disruptions faced by the industry, such as the impact of the pandemic, which brought to light the vulnerabilities within the industry. This discussion also delves into the complex global connections and interdependencies of the chip industry, highlighting the concentration of advanced chip manufacturing in East Asia and its geopolitical implications, particularly within the dynamic of the US-China-Taiwan relationship. Additionally, it covers the backgrounds of key industry figures, including the influence and innovation stemming from the historical turmoil of figures like Andy Grove and Morris Chang during World War II. In the post-World War II era, the potential of atomic energy fueled interest in technological advancements, while leaders like Akio Morita and their wartime experiences pointed towards a future where machines could aid in warfare. The evolution of computing from ancient tools like abacuses to human computers and mechanical computers is detailed, reflecting a growing need for automated computation. The transition from mechanical gears to electrical charges led to the advent of vacuum tube-based computers, culminating in the invention of the transistor by innovator William Shockley. This consequently sparked further revolution in the field through Jack Kilby's work on integrating multiple transistors into a single slab of semiconductor material, further propelling the field of electronics forward. The integrated circuit, later known as the chip, opened up pivotal opportunities in the early days of the chip industry, ultimately leading to significant developments in transistors and microelectronics. The formation of Fairchild Semiconductor by the traitorous Eight resulted in substantial advancements in transistors and microelectronics. This period also saw critical innovations such as Neusser's planar process and Hohen's method of depositing protective layers, which significantly advanced transistor reliability. The integrated circuits developed by Neuss were particularly noteworthy due to their integration into a single block of material without freestanding wires, rendering them vastly more reliable. These advancements found a market with NASA's Apollo program for guidance computers, while Haggerty foresaw the potential of integrated circuits for military applications, eventually securing a significant contract for Texas Instruments with the Air Force's Minuteman II missile. The development of photolithography, which mechanized and miniaturized chip production, played a crucial role in enabling the mass production of tiny transistors, meeting the demands of the space program and military applications. During the 1960s, Texas Instruments recognized that existing mask companies did not have sufficient precision for their integrated circuits and thus decided to make masks and silicon wafers themselves. This period also saw the relentless efforts of individuals like Jack Kilby and Mary Ann Potter in experimenting and running tests to improve chip production, while Morris Chang, fleeing from communist armies, revolutionized transistor manufacturing at TI. Sensing the potential in offshoring production, individuals such as Mark Shepard and Morris Chang embarked on establishing relationships in Asia, strategically aligning the region with the US. Taiwan's Minister Lee played a significant role in forging a partnership with Texas Instruments, ultimately transforming Taiwan's economy and strengthening its ties with the United States. This move resulted in the dramatic shift of semiconductor supply chains across Asia, consequently impacting the region's economies and politics. Meanwhile, in Silicon Valley, Intel co-founders Noyce and Moore set out to revolutionize computing by founding Intel and launching the first dynamic random access memory (DRAM) chip, altering the world's memory storage technology. This period marked the profound socio-political consequences of the semiconductor industry revolution, with figures like Carver Mead predicting an era where computing power would significantly influence society. In the late 1970s, the US faced a post-Vietnam military crisis and pursued advanced computing to gain superiority. This approach leveraged semiconductor innovation from Silicon Valley to develop highly accurate guided missiles and communication systems, laying the foundation for automated warfare. However, the 1980s posed intense competition for the US semiconductor industry, particularly from Japan, whose superior quality chips posed a significant threat. This transformative period highlighted the need for the US to confront Japan's economic and technological prowess. The subsequent period was marked by intense competition and legal battles between US and Japanese chipmakers, mirroring accusations of espionage and protectionism. The Japanese firms had benefited from protected domestic markets and government support, ultimately leading to the competitive landscape of the semiconductor industry pitting US against Japan. In the late 1980s, Japan's economic dominance and technological advances raised concerns in the United States, particularly sparked by the book The Japan That Can Say No, which challenged US dominance and predicted potential Japanese hegemony in various industries. This era saw the resurgence of the US through Micron, an Idaho-based company that navigated the memory chip market through innovative cost-cutting strategies, eventually reviving America's chip industry. The author further explores Micron's battle against Japanese competitors in the DRAM industry, along with Andy Grove's leadership at Intel and Lee Byung-chul's transformation of Samsung into a semiconductor powerhouse. Continuing through the 1980s, Korean companies began to benefit from US-Japan trade tension, seizing the opportunity to sell more DRAM chips at higher prices. Additionally, the US provided technology to Korean firms, enabling them to become leading centers of memory chipmaking. This period was also marked by significant advancements in chip design and chipmaking, with DARPA playing a crucial role in funding research and building educational infrastructure for chip designers. Furthermore, the book touches upon the espionage activities of KGB focused on stealing foreign technology, collectively shaping the landscape of the semiconductor industry during the 1980s. In the early Cold War, the USSR's theft of chip designs and manufacturing equipment from the West failed to guarantee efficient production. Despite the KGB's efforts, the Soviet Union struggled to revitalize its microelectronics industry due to political interference, reliance on military customers, and lack of an international supply chain. These struggles impacted the Soviet Union's military strategy, resulting in inferior missile accuracy and vulnerability in both conventional and nuclear warfare. The author also delves into the transformation of military warfare and the decline of Japan's semiconductor dominance in the 1990s, linking it to overinvestment in the semiconductor industry and its failure to adapt to changing markets. In the 1980s, Taiwan was a leader in assembling semiconductor devices, but it lagged behind in chip manufacturing technology. Morris Chang, an experienced figure in the semiconductor industry, was hired to revolutionize Taiwan's semiconductor industry. With government funding and a radical business plan, he founded TSMC, a company focused on manufacturing chips designed by customers. The government provided startup capital and tax benefits for TSMC. TSMC's deep ties with the US chip industry and its foundry model transformed the global tech sector and allowed for the democratization of chip design. This period saw China's semiconductor industry lagging behind its neighbors and the rest of the world due to radical policies, ultimately leading to the initiation of the Semiconductor Manufacturing International Corporation, SMIC, and its subsequent competition with TSMC and other foundries in producing complex chips for the emergence of smartphones. In the 1990s, the chip industry advanced rapidly, with key innovations such as 3D transistors and Qualcomm's frequency hopping system transforming the landscape. This period also witnessed the rise of fabless chip firms, particularly in the graphics chip market, exemplified by the success of NVIDIA. Additionally, it casts light on the implications of the shift in semiconductor manufacturing from the US to East Asia for the industry's future. The focus then shifts to Intel's high profit margins through its x86 chips monopoly and its establishment of dominance in server chips. Despite the emergence of potential challenges like the RISC technology, Intel remained dominant due to high switching costs and the threat to its monopoly. However, the offshoring trend, especially in the semiconductor industry, had implications for the United States' competitiveness. This era also saw TSMC facing challenges after an earthquake knocked out power in Taiwan, prompting a shift in focus within the US semiconductor industry from defense collaboration to looser export controls. The rise of fabless chip firms and the implications of the shift in semiconductor manufacturing from the US to East Asia are also explored. The semiconductor industry has experienced a seismic shift as it faces pivotal changes in technology, geopolitics, and global trade. In a quest for technological dominance, global players like Intel, Samsung, and TSMC turn to ASML, a Dutch lithography company, to navigate the complex landscape of EUV lithography. The deployment of ASML's EUV tools was instrumental for chip manufacturers, allowing for the continued scaling down of transistors. As companies like Global Foundries had to abandon cutting-edge nodes and Intel struggled with market share due to challenges in adapting to AI trends, the semiconductor industry witnessed a profound, intricate landscape of competition, strategic decisions, and the challenges in maintaining technological leadership in chip manufacturing. The prominence of China in the semiconductor industry has raised concerns, with the country's ambitions to reduce its reliance on imported chips and develop technological self-sufficiency. China has aggressively pursued dominance in the semiconductor industry by acquiring technology and expertise, including the involvement of companies like IBM, AMD, and ARM in technology transfer arrangements. Furthermore, Tsinghua Unigroup's ambitious efforts to control the global semiconductor industry through acquiring stakes in major companies and Huawei's rise have reshaped the competitive landscape. The US-China technological competition has been characterized by various instances of friction, such as the US government's perception of Huawei as a strategic threat, leading to stringent restrictions on the company. These measures, along with China's pursuit of technological independence, have shaped the semiconductor industry's global dynamics. Additionally, the US government's response to issues of technological dominance, including the case of a former Micron employee's attempted theft of trade secrets, has highlighted the complex dynamics and geopolitical considerations involved in this competition. Furthermore, the semiconductor supply chain's integrity and its significance in the global context have been brought to the forefront, particularly with the actions and strategies of various countries and companies such as the USA, China, Huawei, Fujian Jinhua, and Taiwan in relation to semiconductors and microelectronics. The challenges faced by companies in procuring semiconductors, military and geopolitical implications, and the impact on global supply chains have underscored the importance of the semiconductor industry in the 21st century and the interdependencies of various countries and industries. However, amidst these complexities and challenges, the semiconductor industry looks towards the potential future of semiconductor technology, including a 50-fold increase in transistor density on chips through new tube-shaped transistors and the increasing investment in specialized chip design for AI. As the industry navigates the implications of the decline of Moore's law and the emergence of heterogeneous compute, it continues to remain a critical component of global geopolitics and technological advancement. Moreover, the book delves into the history and evolution of the semiconductor and chip industry, covering the impact of various factors such as government support, competition from countries like Japan and South Korea, the role of key players like Intel and Micron, issues like intellectual property theft, and the development of semiconductor technology. It provides insights into the complexities of multinational supply chains and the impact of geopolitics on the industry. In conclusion, the semiconductor industry is at a critical juncture, poised at the intersection of technological innovation, global competition, and geopolitical tensions. As players like ASML, Intel, Samsung, and TSMC navigate the intricacies of EUV lithography and strategic decisions, and amid the rise of China as a major player, the semiconductor industry continues to shape the economies and geopolitics of countries worldwide. As the industry looks towards the future and grapples with challenges and advancements in technology, it remains a pivotal player in the global landscape, with ramifications reaching far beyond the realms of commerce and technology. Thank you so much for watching this video. Your support means the world to us. If you enjoyed it, don't forget to give it a thumbs up and share it with your friends. We'll see you in the next video.